So the converse of the Pythagorean theorem is going to use the same theorem that Pythagoras proved, which is a squared plus b squared equals c squared. But instead of trying to find c, the long side, the hypotenuse, like we've done in all of the previous examples, we're going to be looking for one of the other sides, either a or b. And when we're doing these problems, sometimes you can tell from the picture which is the shortest side, but it doesn't really matter because A and B are added together. And we know that with addition, we are allowed to move the pieces around because of the commutative property. So it doesn't really matter if we solve for A or B. Sometimes you can tell from the picture I usually like to solve for A because sometimes my handwriting is messy and my B's end up looking like sixes. So if I'm solving for a side that's not C, I usually like to solve for A just because it's an easier variable for me to work with. So when I look at this problem that says a 30-foot ladder is placed 10 feet away from the house and it just reaches the peak of the roof, how high is the peak of the roof? So they've told me that this length here is 30 feet, and they said that the ladder is 10 feet away from the side of the house. And I love on this picture that they have given me the right angle because when I look directly across from that, I can tell that this is the longest side, that's the hypotenuse, that's the letter C. So I'm going to go up to my formula and I'm going to plug in 30 for C and then put the exponent 2 on it for 30 squared. Now in this picture, I can tell that this 10 is probably the smallest side, which should be A. So I'll go ahead and plug it in there for A, which means I'm solving for B, which is the longer of the two legs. Again, it doesn't really matter if you plug the 10 in for A or if you plug the 10 in for B, because addition is commutative, we can move the pieces around. Either way, we will end up with the correct answer. I know that 10 squared is 100. I still don't know what b is, so it's still there and it still has the exponent 2. And I know that 30 squared, well, 3 times 3 is 9, so that'll be 900. And now I'm going to use all of those skills that I learned to solve equations. I want to get the b by itself. I want to isolate the variable b. So I'm going to begin by circling it, and I need to get rid of this 100. It's a positive 100, so I'm going to subtract 100. That becomes a 0 pair. And what I do on one side, I must do on the other. So now I have b squared equals 800. And I'm not quite done yet because the b is not by itself. In order to finish this problem, I need to square root both sides. And when I do that, b is now by itself. Why is the b by itself? Well, b squared means b times b. And if I take the square root of that, I'm going to just end up with one single b. Or to prove this with a number, let's use the number 7. Let's do 7 times 7. Well, what is 7 times 7? That's 49. And what is the square root of 49? Just 7. So what would the square root of this be? Just 7. So the square root of b squared is just b. Now I know that 800 is not a perfect square, which means if I was going to do the square root of 800, in order to come up with an exact answer, or an answer like what we would come up with on a calculator, I would have to use a calculator, and I would see that this comes out to be 28 with a pretty long irrational decimal. So instead, I can simplify 800. Now I'm going to have to remember that lesson we did on simplifying square roots. I know that I could break 800 down into 100 times 8. The square root of 8 times the square root of 100 would give me the square root of 800. And the square root of 100 is 10. So now I have 10 root 8. And when I look at that, I know I'm not quite done because I know 8 could be broken down even more. Because hiding inside of 8 is the square root of 4 times the square root of 2. And the square root of 4 is 2. And the square root of 2, I can't do. It's irrational. So my final answer will have the square root of 2 in it, because I can't do that calculation. And the square root of 4 was 2, and I already had this 10 on the outside, and 10 times 2 is 20. So the simplest answer I could give to this problem is that the height of the roof, or how tall this building is 20 root 2 feet, which we just figured out on the calculator was about 28 feet. Here's another problem where we could use the converse of the Pythagorean theorem. So we're still using that same a squared plus b squared equals c squared. I'm just not going to be solving for c. This says the ramp on a delivery truck is 12 feet. Okay, so this ramp is 12 feet. The edge of the ramp on the ground is 6 feet away from the truck. So on the ground is 6 feet away from the truck. Now on this one they didn't draw the right angle, but I can see by the picture that the right angle is there. So that must mean 12 is the longest side, the hypotenuse, which is C. What is the height of the delivery truck bed? So they're asking me, what is this right here? Now that to me looks like it's going to be smaller than the other side, so I guess I'll be solving for A. But again, it doesn't really matter as far as calculations go if you put your variable as A or B. What does matter is that you use 12 for C. That is the longest side. I'll go ahead and use 6 as B, and A is what I don't know. Now I've got a squared plus 6 squared, 6 times 6 is 36, and 12 squared, 12 times 12 is 144. And I go back to my equations and my solving equation skills. I'm going to circle my variable, which is a, and I have to get rid of plus 36. I do that by subtracting 36 from both sides. This becomes a 0 pair, and now I am left with a squared equals, and I have to do some subtraction where I'm going to end up borrowing, and I'll find that I end up with a squared equals 108. But I'm not quite done. The a is not by itself. It is not yet isolated. In order to get rid of the exponent 2, I have to take the square root of both sides. And that will get rid of that exponent of 2. Now I'm looking at the number 108, and I know that's not one of my perfect squares. So if I get my calculator to see what this number actually is and do the square root of 108, I find that it's about 10 feet, 10.39. It's an irrational decimal. It's not going to repeat. It's going to go on forever. I've got a square root of 108, and I could simplify this. I'd like you to finish simplifying this and give me a final answer of a equals. It will have a square root in it, and it will have the units feet. I'd like you to finish that problem, the simplifying of the exponent, or excuse me, of the square root on your own tonight, and bring your answer tomorrow to class. And here's one that I will ask you to solve completely on your own. It says Joe is on a sidewalk 100 feet away from a tree. Jim is on a perpendicular sidewalk that's 70 feet away. So we're talking about this distance here is 70 feet. How far away are Jim and Joe from one another? I can tell you that this is going to be the right angle, so that should give you a clue about what you are solving for on your own tonight.